Welcome to the course Digital Transformation and Technological Innovation. So, we are into our second module, that is digital infrastructure. So, let us start from where we stopped in the previous session. So, in the previous session we were talking about the last few minutes we were talking about the contactless cards and how they are embedded with microchips and radio antenna, and therefore users they just simply need to tap or wave near a terminal, and the information exchange, whatever necessary information exchange that needs to be done, that will happen, right. So, whenever we visit a retail store, now the terminal is there which is capable of reading from these contactless cards, right. So, we just need to tap or wave, and NFC, near field communication NFC technology would be used to exchange the necessary information. And what is NFC? This is again a specialized form of radio frequency identification, which is RFID. We will talk about this later also. So, essentially using the microchip and the radio antenna. So, whenever we wave close to a terminal or tap close to a terminal, that through the radio signals the information exchange happens, and that is how the processing, maybe a payment, that happens at a retail store, right. Problem is the security concern that can be there, the card data can be scanned. So, this is one issue that goes with the contactless cards, and that is why generally if we talk about the credit cards and the debit cards, generally if this kind of functionality is there in the card, that means they can work like a contactless card, then there is a cap that is imposed by regulatory agencies, a cap in the sense of amount, maximum amount that can be transferred via this mechanism, via tapping or waving mechanism, right. Moving on, next is point of sale system. So, what point of sale system is about? So, this is another example of information system. So, it is a transaction processing system. We have talked about that in the in the first module, that is fundamentals of information systems. So, a transaction processing system to facilitate sales transactions and obviously generate invoices and other reports that might be relevant, right. So, this is another example of information systems. We touched upon this also a little bit in our introductory module, right. Now, POS devices are typically used as part of this point of sale or POS system. So, what are POS devices? So, POS devices, these are terminals, right, that capture sales data with the help of other input and output devices, right. So, these POS devices, they are there are so many retail stores, and you will see very frequently POS devices there, and most of the transactions that happen nowadays, they happen through POS devices, right. So, because of that, because most of the stores, they have transformed themselves into more modern computerized or digitized stores, and because of that there is a huge spending that happens on POS devices. So, spending on POS devices is very common item in IT budgets, for especially in customer facing industries. So, industries, for example, retail and e-commerce and many other industries which are customer facing, POS devices very common item where the spending from the IT budget goes, right. So, when we talk about the input and output devices that will be used along with the POS devices, so those are barcode readers and scanning devices, right. So, then let us move to the barcode scanner, right. So, what is a barcode scanner? So, barcode scanner, it employs a laser scanner to read a barcoded label. So, there are lots of products, most of the products, they will generally have this barcoded label, and the information about that particular item and the other details, price and other details, that would actually be there in the barcoded label. So, for faster processing, to avoid a long queue in a retail store, these barcode scanners, they will quickly this is a laser scanner, quickly read the barcoded label and pass the data input to the connected system, which is the POS system, right. So, the barcode scanner, so it sort of takes the input from the barcode label, right. So, you would see, where are the examples? You would see store checkouts, warehouse inventory. So, there you will see the application of these barcode scanners, right. In case of retail, you will see that as part of the POS system, right. So, then another example for barcode scanner is our smartphone camera. So you might have used yourself that sometimes you use your smartphone camera to scan a barcode, use it like a barcode scanner and scan some barcode, and then you launch websites, right. So we use nowadays the latest smartphone cameras, and you can use them like a barcode scanner, scan the those barcoded labels, and it would be a URL website, launch those website, you land on that website, and it would be related to some support. So there would be labels on packaging, there would be labels on ads, and it would be supported to some promotional offers and discount offer or some supporting websites, and you land on that, right. So this is about barcode scanner. So barcode scanner, they become important part of POS system along with the POS devices. So they act like input device supporting the POS terminal. Then moving on, so we talked about when we are talking about the contactless card, right, we talked about the RFID. So one of the more popular application of RFID is in the form of RFID tags. So radio frequency identification tags, RFID tags, so very commonly used across industries. So what this is about, so RFID tags, they actually employ a microchip with a radio antenna, and this microchip and radio antenna, this combination is used to transmit back the unique identifier and other data to RFID readers. So RFID tag would be having the microchip and radio antenna. So microchip will have the the information and about that particular item on which you have attached the RFID tag. So then using the radio antenna, right, the information would be transmitted back to some RFID reader, right. So there would be RFID readers installed, and they would be able to read the information that is there in the RFID tags, and RFID tags would be attached to some items. So therefore that information would actually be transmitted, right. So a benefit with the RFID tags is that they are small compared to barcode labels, and then faster from a distance the reading can happen, right. So RFID readers typically they are typically placed at specific points to detect tag movement, right. So there is another benefit, another important benefit. So retail stores or other stores, right, or fashion stores and other jewelry stores and other stores which are having high value items, or they apart from other items, they also have certain high value items in their in their shelves, right. So RFID readers and RFID mechanism, tags and readers put together, they are very important for them to detect movement. So if there is a any unwanted movement, and the tag would be there, so therefore RFID readers can be installed in such a specific point, so that if there is a movement around that particular specific location, particular specific point, then that tag movement would be detected, right, and an alarm would be raised. So this helps in many situations where the high value items are involved. So example for this is in store RFID readers, they track the shelves inventory for restocking by reading the RFID tags placed on retail items, right. So this is another use case for this, that in your retail store shelves you can track the stocking labels, and when there is a threshold that is reached, so that can be that signal can be raised, right. So because the RFID readers, they can read the RFID tags from the distance, and therefore the restocking can be checked, right. So this is another use case for RFID tags and the readers. So moving on, now how RFID tags work, right. So RFID tag chip actually has EEPROM, right. So what is EEPROM? EEPROM is electrically erasable programmable read only memories. We have earlier talked about ROM, read only memory. So this is sort of permanent kind of a storage that we have, but this is erasable. That means we can have while the item is there in the store, we can have information about that item in the RFID tag chips, but later the same tag can be reused for some other item, once the previous one is sold off, then therefore electrically erasable, right. So, this is sort of permanent information that is there, and so EEPROM kind of is used in the RFID tag chip, right. And another benefit of using EEPROM, so earlier older versions of RFID tags used to have different technology, EEPROM actually, and so here the benefit is that wireless update can happen for the item information. So, wirelessly update item information. So, RFID tag chips has an EEPROM to store and also wirelessly update. So, therefore, the older RFID tags which did not have EEPROM, so will have to take the the RFID tag closer to the reader for you to erase and update the new items information, right. But now because of so much fast movement that happens in the stores or warehouses, so it might not be it is not very productive, right. So, therefore, EEPROM is so the latest RFID tags are using EEPROM, so that wireless update can happen. So, that extra movement can be avoided just for updating RFID tags. So, there are productivity efficiency gains simply because of changing the kind of memory that we are using in the RFID tag chip, right. So, how this works further, RFID reader sends a specific radio signal, so we are talking about how this update is done. So, RFID reader sends a specific radio signal that the tags antenna, RFID tags antenna converts into a precise voltage pulse to erase and rewrite, right. So, through RFID reader this process can be initiated, radio signal will go to the RFID tag, the antenna is there, it will receive and it will convert that into a precise voltage pulse, and therefore, electrically erasable that part of the EEPROM will work and erase and rewrite. So, moving on, next is touch sensitive screens, right. So, we are still this is another example of input devices, right. So, RFID tags and the earlier example that we talked about, POS devices, the barcode scanner, right. So, essentially we are taking inputs. So, what we are discussing in all these examples essentially input devices, how the data is taken and then the processing happens at some information systems, right. So, now next up is within that category is touch sensitive screens, right. So, what are touch sensitive screens about? So, these are display device, right, that doubles as an input interface. So, actually a display device or display screen, they are actually output device that we will be talking later, right. But this one, if it is a touch sensitive screen, that it will also provide a mechanism to give input. So, doubles as input interface. How it does that? By employing a touch sensor panel layer, right. So, a touch sensor panel layer over visual display. So, over visual display there would be another layer that will act like a touch sensor panel layer. So, typically the visual display is more likely going to be LCD or LED or OLED screen, right, and on top of that there would be touch sensor panel layer. So, that that particular screen also works as a input interface. So, right, you can interact with that screen, right. So, what is the underlying for the interaction, there has to be some mechanisms. It should be for example keyboard we are able to type, and mouse we are able to click, right. So, similarly here how does it work? Rely on pressure, electrical conductivity or infrared light beams, right. So, different technology for different kind of products that would come under touch sensitive screen, right. So, pressure or electrical conductivity, so many times it would be combination of that depending on the use case. If it is a more industrial use case, maybe pressure plus electrical conductivity would be used to improve the longevity of that product. And if it is like a smartphone or something, then it might just simply be electrical conductivity based. Then there are infrared light beams also to cover certain scenarios. So, direct interaction is feasible with the direct interaction with the digital content is feasible through simple gestures like tapping, swiping or pinching, right, because touch screen direct, just like we walk with our smartphones, and the latest one have touch screen for a long time now. So, similar kind of screen we are talking about in case of display. So, example smartphone screen, that is an example touch sensitive, more of a more works using the mechanism electrical conductivity. Then ATM screens combination of pressure and electrical, right. So, you would all of us use ATM. So, we have to press slightly hard. So, slightly physical pressure is also there, that improves the life of the machine also. So, ATM screen, airplane seat back screen you might have seen. So, airplane seat back screen also they use the combination of pressure and electrical conductivity, because life of airplane is much higher. So, therefore, you would like to increase the life of the airplane seat back screen also. You would not like to, as an airline firm, you would not like to change those screen very quickly, right. So, extra cost, right. So, there also similar thing. Interactive whiteboards, so in classrooms they might be used. So, they might be size of the whiteboards might be quite big, because they are being used in a learning context in a classroom setting. So, they are typically infrared light beams, they scale well to the size, screen size. So, therefore, that technology is more common there. So, this was about touch sensitive screen. Moving on, the next one is pen input devices. Now, while we talked about the screen, right, now if we do not use the pen input devices, how do we interact with the screen? So, we will be using fingers or mouse is another mechanism, because it is touch screen. So, we can count finger, right. But if we are looking for more precise interaction, so we want more precise interaction with the touch sensitive screen, then pen input devices would be the instruments, right, that we can think of using. So, handhelds, what are pen input devices? So, these are handheld instruments and are used to interact with a screen with more precision than a finger or a mouse, right. So, in comparison to using a finger, we would be able to control or interact with the screen or whatever thing that we are working using that screen and the computer, right. So, work by, how does it work? So, work by detecting the pen's location and pressure, right. So, pen's location and pressure, what is the underlying technology? So, first thing is screen, we have already talked about, has a special sensor layer called a digitizer, right. So, that screen should support the the touch pressure. So, special sensor layer would be there. Then in the case of this pen that we talked about, so it will have pressure sensitive spring, right. It will have pressure sensitive spring and a sensor, right, to understand, to measure that pressure, the pressure that we are applying onto the screen. The sensor will capture that and then communicate back to the system, right. And there would be side buttons also typically in the in the pen, like the one that I am using here. You can see the side buttons here, and right. So, side buttons and the Bluetooth also, some high end pen devices, they might have Bluetooth send commands, so extra commands can be sent, right. So, how it is used by digital artists, designers. So, digital artists, designers are the typical users of pen input devices, because they might be working with some design, image or artwork, and therefore, finger will not give them sufficient precision, right, and they might be using the touch screen, and the pen input devices will actually fill in that gap where they can achieve extra precision, right. Moving on, next up is what are different forms of output devices. So, we have completed our discussion on some of the different input devices and how they can be used. Now, we arrive at different forms of output devices. So, here in the how part is not that important, the what part we can look at. First up is display monitors. So, now there are lots of options. So, for any firm or individual or professional, this also becomes a decision point as to what kind of display monitors they can go for. So, flat panel displays. So, essentially flat panel displays are the more common displays now. The older technology is now obsolete. So, display monitors, more often than not, they are actually flat panel displays that we get nowadays. So, they employ different technology to light up pixels, right, different technology light up pixels that are there in the screen, the image or the lights that we see on a screen, right. So, there are pixels there and which are being lighted up, right. So, what is a pixel? So, this is a dot on a display screen with on off modes, right. So, dot on a display screen with on off modes. The pixels and the lighting can be on and off, and accordingly the image or whatever you are seeing, lights or images, whatever you are seeing at the screen, this is managed through pixel, which is nothing but a dot with an on off mode, right. So there are different technologies at work to manage this pixel, when it is on and off. So what is that underlying technology to manage this, in terms of lighting the pixel, right, on and off and lighting the pixel. There are different technology that work. So let us look at some of these options that are there. So first one is liquid crystal display. So what is a liquid crystal display? This is LCD, in a abbreviated form. This is the common term that people use, LCD, which is actually the liquid crystal displays. What this is about? In this one we have layers of charged liquid crystals, and they are placed between clear plates that act as shutters to block or let through light, and from a fluorescent tube, right. So fluorescent tube is working as a backlight, is employed as a backlight, and that light will fall on the it is lighting the screen from the back side. So it is working as a backlight, and the light is coming, and these crystals, liquid crystals, they are working like a shutters, where they are doing the on off thing. So like when the light will go, or when it will not go, when to block and when to let through, right. So this kind of technology is used for liquid crystal display LCD monitors, right. So now it is more of a obsolete. You won't find too many products which are actually LCD products being sold nowadays. So but this was, if we look at in terms of application where use case, so great for bright rooms. So if you are having a bright rooms and LCD monitors, LCD display, they will be able to show the pictures or the images or the screen much better, right. Moving on, next one is light emitting diode or LED screens or light emitting diode. So LED is the common term that is typically used, right. So this is also an LCD, right. So only difference is that LED employs light emitting diodes. So light emitting diodes as the backlight. So in case of LCD, it was fluorescent tubes that were being used as a backlight, but replacing the fluorescent tube with the light emitting diodes as the backlight option. So otherwise LED is also an LCD, only the backlight technology is being changed. So what is the benefit? Is there any benefits? Yes, better contrast and lower energy consumption, because these light emitting diode you can manage whenever it is off, that the energy consumption goes down. So therefore lower energy consumption is there than LCD. So this is affordable, great for bright rooms. So the LCD is nowadays obsolete. So the what is the option? The affordable option, that is LED. So most of the screens that we nowadays go for, you will actually be buying a LED if you are going for the affordable category, and great for bright rooms. Moving on, next is organic light emitting diode, OLED, right. So this is this one is slightly different technology. So this is different technology from what we just discussed in terms of LCD or LED, right. So they are self lighting pixels. So earlier we were talking about the backlight in both the case LCD and LED. So fluorescent tube or light emitting diodes, but here the pixels themselves are sub lighting pixels. And how that is happening? So these self lighting pixels function by exciting organic compounds with electricity. So electricity is being used and thrown on the organic compounds, and using that self lighting pixels are there. So we do not use the backlight in organic light emitting diode. So the organic word is coming because we are using the organic compounds to make that lighting happen. So organic light emitting diode, organic compound is being used, electricity is applied, and the self lighting pixels, we are able to arrive at self lighting pixels, and that are used. So different, right, no backlight. So different technology, expensive, right. So this is OLED is expensive technology, best for dark rooms, right. So in darker rooms it is considered to be the better options. Then improved contrast. So contrast improves. Energy consumption, this lowered in comparison to LCD or LED. There are lots of benefits that goes in favor of OLED. So, future is more towards OLED because lower energy consumption. So, this goes in favor of OLED and improved contrast in comparison to. So, LED is the affordable option, but you get better contrast and in terms of lower energy consumption in case of OLED. So, all these are the favorable factors, but then it is expensive, but over a period of time as the production technology improves, we might see that the cost or the prices of OLED going down, and therefore, in future OLED might eat up the market that is being held by LEDs, right. So, this was about OLED. Moving on to the next one. Another option is plasma, but that is also obsolete. So, this was also best for dark rooms. So, here just for the completeness sake we are covering, but this is obsolete. This self emissive pixels are used. So, this is also different technology than LCD/LED. So, different from that. In terms of that self lighting pixels or in this case self emissive pixels are there. So, OLED and plasma are similar in that small context. So, self emissive pixels that function by charging gas or plasma with electricity. So, in case of OLED is for the organic compound that was being that was being charged using electricity. Here it is the gas or the plasma that is being charged using electricity, and that facilitates the functioning of self emissive pixels, right. And so, again here also there is a no backlight and different technology. Now, what is the problem? Higher energy consumption, right. So, higher energy consumption than LCD and LED. So, therefore, this could not scale and was obsolete. So, it was actually obsolete long back. LCD itself, while LCD was popular and the manufacturing in a large scale could happen for LCD, that could not happen the plasma, and therefore, LCD was winner in that LCD versus plasma competition. And later LCD also became obsolete because LED came in and better contrast, lower energy consumption. So, what are the options that we are left with? Mainly LED for the affordable category, and then OLED for the expensive better category. But the future again, as I said, is more likely to be OLED. Then moving on, the next point is about the quality of a screen image, right. So, how do we judge the quality of a screen image? So, images that typically are shown are composed of millions or more pixels. So, you would see when you are setting your screen resolution in your computers, you will see the options. There would be height and width options, and most of those numbers will be more than 1000 cross, more than 1000 something. So, essentially if you multiply those 3 zeros there, 1000 cross 1000, those options, so essentially more than a million or more pixels. Those kind of options nowadays we get in recent screens, right, displays. So, images shown on display are composed of a million or more pixels. More pixels means what? More pixels means that you have clear and sharper image, right. More resolution, more pixels, you can clear and sharper image. You can even zoom into that image and you will see you will have good clarity on whatever is there after zooming in, right. So, how do we measure this? So, measure by resolution. What is the resolution? It is nothing but total number of pixels contained in the display. So, when we talk about a screen, we talk about resolution. So, when we say resolution, essentially we are saying total number of pixels, and more the pixel, clear the picture. So, essentially when you are going for a screen, you should be looking at what is the resolution. So, a smaller screen with higher resolution will be able to show better image, right. And if it is a larger screen, then those pixels are to be distributed, and therefore, the quality might slightly go down, right. So, we will stop at this point and we will continue our discussion in the next session. Thank you.